Hi, and welcome to 2.3 Graphing Motion. In this lesson, students will be able to analyze motion graphs in order to describe the motion of an object, and students will be able to describe the difference between and calculate average and instantaneous speed and velocity. So those are like four separate things right there that look like this. So let's focus on the average speed first. Average speed is the total distance divided by the total time. This is the equation that you should remember for average speed. The instantaneous speed is the speed at a specific time. You could say at 4 seconds, how fast were you going? And visualize looking at a speedometer and saying, oh, I was going 20 meters per second precisely at 4 seconds. That might be different than your average speed for the whole trip. And just like there's average and instantaneous speed, there's average and instantaneous velocity. The difference being the average velocity is the total displacement divided by the total time. So what does this instantaneous velocity look like on a graph? The instantaneous velocity is the velocity of an object at some instant or specific point in the object's path. The instantaneous velocity at a given time can be determined by measuring the slope of the line that is tangent to a point on the position versus time graph. In this example that's shown, the slope is constantly changing. And since the slope represents the velocity, this is an example of a changing velocity. And this object is actually accelerating. And we're going to do acceleration in the next lesson. But I wanted to show you that sometimes the slope changes like this. So the velocity is constantly changing, but at 3 seconds, you can determine how fast were you going at 3 seconds by drawing a line that's tangent to this curve, meaning it only passes through that one point at 3 seconds. And if you find the slope of this, they made it a black dotted line. If you find the slope of that line, that would tell you the instantaneous velocity at 3 seconds. So in that case, it happened to be moving at 12 meters per second at the 3 second mark, and then it gets faster and faster because the slope gets steeper and steeper. So at that instant, that's how fast the thing is going. That's instantaneous velocity and instantaneous speed. So typically in the classroom, I take the kids out into the hallway and I do some crazy walks, and I give them all timers, and we stand 1 meter apart from each other. Now we would have to stand even further apart, but they would start the timers all at the same time and then stop the timer as I go past them. So I made this slide to kind of represent that. So this person's moving really slowly, the speed is very low, and then all of a sudden they start skipping and go faster, faster, faster. And you could plot this point. So then we would all come back into the classroom and it'd be like, okay, you were at position 1, what time do you have? You were at position 2, what time do you have? We'd make a data table, we would plot it. Then we would say, what is the, so this is the time is on the x-axis, and the displacement, the number of meters, is on the y-axis. And it says, what is the average speed for each style of walking? So here's the old person shuffling along, and then this was that crazy person skipping. So what is the average speed for each style? And the way to do the average speed is the total distance over the total time. So we went 2 meters divided by, and that looks like 9 seconds. So the first speed was 0.22 repeating meters per second. And we could even put a bar above this because it's the average speed. The average speed for the second funny walk, how many meters did they go? They went 1, 2, 3 meters in the y-axis. So 3 meters. And how many seconds did it take them to go 3 meters? 1, 2, 3 seconds. So the average speed of the second funny walk was 1 meter per second. So you went faster, and that was slower. So since we have a nice linear graph it's not curved like we did before, and we had to find the line that's tangent to it. The line tangent to this curve is just that line, and the line tangent to this curve is just that line. So my point here is, if you know the average speed, and you're not changing your speed in this time interval from t equals 0 seconds to t equals 9 seconds, then you also know your instantaneous speed. And that's going to come up in the next few word problems. So you just find your average speed. So along this whole time, I was moving at 0.22 meters per second constantly. So it says, what is your instantaneous speed? Right at 5 seconds, right here, I know I was going 0.2 meters per second. And you could even say, what is the instantaneous speed at 11 seconds? Well, I know during this leg of the trip, my speed was different. The average speed was 1 meter per second, and that wasn't changing at all. So if they had asked at t equals 11 seconds, what's your instantaneous speed? All you have to say is 1 meter per second. Now it says, what is the average speed for the entire trip? Now remember, the average speed is the total distance divided by the total time. We went 5 meters in 12 seconds, which works out to be about 0.42 meters per second. That's the average speed for the whole trip, somewhere in between these two speeds. Now we can do an example here. It says, on a highway, a car is driven 80 kilometers north during the first hour of travel. So you could even make yourself a nice vector diagram. 80 kilometers north, and that takes 1 hour. Then 50 kilometers south, and then during the next half hour of travel, and then 40 kilometers north in the final half hour. What is the car's average speed for the entire trip, the average velocity for the entire trip, and the car's instantaneous velocity 30 minutes into the trip? So part A, we need to know the total distance that you went and the total time. So we need the total distance. And when you add all those distances together, you get 170 kilometers. Now we don't care about the direction because distance is a scalar. So we could do the formula for average speed, d total divided by t total. And then you just plug in 170 kilometers. And what was the total time? 1 hour plus a half hour plus a half hour. So that's 2 hours total. So your average speed is 85 kilometers per hour. And at this point, we could leave it at kilometers per hour for this. We're not going to plug it into any other equations that we would need these units to agree with anything else. So for now, that's totally fine. Now for part B, very slightly differently, they're asking for the average velocity. So instead of the total distance, we need to find the total displacement. And displacement is a vector, and direction matters. That's why we drew this vector diagram over here. Now I like to kind of space it all out like this so we could see the vectors. Technically, you could write them all on top of each other, something like this, but it's a little harder for me to show you that. But if I was doing it on my own, I might do that. But I started here and I ended here, so my resultant vector graphically should look something like this. I started here, then I turned all around, back and forth and back. I ended at this position, so my resultant vector looks like that. But what is the magnitude of my resultant? I know it's pointing north, but how would I find the magnitude? You have to remember that 80 kilometers was north, and the 40 kilometers was north, the 50 kilometers was south. So you make that negative, and then we could kind of add like we did before, but we're actually going to subtract the 50 kilometers. So it looks something like this. 80 minus 50 plus 40. Or you could say 80 plus negative 50 plus 40. And either way, you still get 70 kilometers. So that is the total displacement. And now the average velocity is the total displacement divided by the total time. It's a little confusing because it looks the same, but remember this was distance and this is displacement. So you use the 70 kilometers, and by the fact that it's positive is also telling you the direction that it's going north, and it still takes you 2 hours to do that. So 70 divided by 2 is 35 kilometers per hour, which is less than your average speed. Now for part C, it says, what is the car's instantaneous velocity 30 minutes into the trip? So you have to determine what part of the leg is that. You went 80 kilometers in the first hour, so 30 minutes into the trip occurs around here on our vector. You could think of it that way. So we're looking for the instantaneous velocity. If we knew what your average velocity was during this leg of the trip, we would know your instantaneous velocity. So that's what we're going to do. We went 80 kilometers in 1 hour. So that's the velocity that we need to do. Now I'm going to call that V1 because that's the first leg of the trip. And we'll call this D1 over T1. So the average velocity during the first leg of the trip is 80 divided by 1 hour. So you were going with an average velocity of 80 kilometers per hour. Now, there's not enough information in the problem to tell you if you were slowing down or speeding up during that whole time. So you have to assume that this is your, that you were traveling at the same velocity the entire time. And if you were traveling at 80 kilometers an hour for an entire hour, then at 30 minutes, you were traveling with an instantaneous velocity of 80 kilometers per hour. So that's how you handle these instantaneous velocity problems. I think there's a few of that on the practice worksheet for this assignment. Now here's a kind of tricky one. You are running 20 kilometers. Your average speed during the first 10 kilometers is 8 kilometers per hour. What must your average speed be over the next 10 kilometers in order to have an average speed of 4 kilometers per hour for the entire trip? So pause it and try it on your own and see what you come up with. All right, hopefully you paused it and thought about it a little bit. Did you think that, okay, I went 10 kilometers, so that's half. So I had 8 here, and I want to get to 4. So does that mean that I need to have a speed of 0 kilometers per hour in order to get to 4 kilometers per hour for the whole trip? That's not how that works, right? Because if you went 0 kilometers per hour, then you're just standing at the 10 kilometer mark and not doing the full 20. So how the heck do you do this? The first step is to figure out how much time does it take you to finish the 20 kilometers for the full 20. So we'll do the average speed for the total trip is equal to the the distance total divided by the time total. Now we want the average speed to be 4 kilometers per hour. And the total distance that you're traveling is 20 kilometers. Just by looking at those two, that's going to tell you how much time it's going to take you total to do that. So you cross multiply, you get 20 is equal to 4 times t. So the total time is equal to 5 hours. Now you know the total time for 5 hours. Let's figure out how much time did it take you to go the first 10 kilometers at a rate of 8 kilometers per hour. So I'll call that S1. So your average speed over the first leg, and then you want to know how much time that took. So you were going at 8 kilometers per hour over a distance of 10 kilometers. How much time did that first leg take you? So again, you cross multiply, 10 is equal to 8 times t, and then you do 10 divided by 8, and you get 1.25 hours. So of the 5 hours, you were traveling at 8 kilometers per hour for 1.25 hours. So the majority of the time you were traveling at a different speed, and that's why it doesn't work out to be, oh, it's just half, and 8 plus 0 divided by 2 is 4. It doesn't work like that, because that would assume that you're traveling at 8 kilometers per hour for half of the time when you're only doing a small portion of that. So the majority of the time you're traveling at a slower speed, which affects the outcome. So you have to figure out, okay, for S2, we know we want to go 10 kilometers, but now we know how much time we're taking. So what is the average speed that you need to do this? Oh, sorry, that looks like an 8. This is 10 kilometers, and this is 5 hours minus 1.25 hours, or 3.75 hours. And now you can do that division, and the average speed that you would need to travel at is 2.6 repeating, or 2.7 kilometers per hour. If you traveled at this speed for the next 10 kilometers, you would have an average speed of 4 kilometers per hour for the whole trip. So that's a little bit of a tricky one for you. And that's about it. Thanks for watching. Have a great day.